Hi, welcome to part two of our leaf tissue data videos. Last time we talked about nitrogen. This time we're going to talk about phosphorus. We went through the tale of three tissues about how the leaf tissue nitrogen and the plant content of nitrogen did not correlate very well, and looked at some of the other nutrients at a snapshot. But we're going to dive a little deeper today into what we found on phosphorus. So similar to the tissue leaf nitrogen percentage on that chart, now you are seeing leaf tissue percentage going up the left side here on the y-axis, and going left to right, you'll see the phosphate pounds per acre that was associated with each of these leaf tissue poles. Again, like with leaf, you see the level of sufficiency between 0.25 and 0.45. I actually think this was up to 0.5, but I didn't graph it that tall. Everything fell within sufficiency and everything that we tested in this subset of data. And you'll see that our content varied from 20 pounds an acre all the way up here to these outliers at 60 and nearly 80, but the majority of our data is falling between 20 and 55 pounds per acre. So if you go up, if you remember from leaf tissue, if you go up one of these grids, all of these are associated with the exact same quantity of phosphate in your biomass. So everything at 30 had tissue barely over 0.3 all the way up here to 0.4, but they all had 30 pounds per acre. So just because you're at a 0.3 doesn't give you a yield trajectory. You know, if you hear someone say, well, you've got to be at 0.4, otherwise, you know, you can give up on that crop. Well, not necessarily, because I could be at below a 0.3 and have 41, 42 pounds of phosphate uptake, or I could be at a 0.4 and be at 28 pounds of uptake. Let me show you how that transcribes over to yield potential. So with the phosphorus accumulation, or actually phosphate is what I converted these to, with phosphate accumulation at the growth stage at which these have been taken, and these were all taken at the same growth stage, the ones associated with 20 pounds of uptake have approximately 160 bushel yield goal, all the way up here to 320 and a little higher. So a lot of phosphate there. Now we'll get into in a moment how much of that is needed versus how much of that might be luxury consumption in the way of quantities. But the tissue does not give you any indication of whether you have less or more than you need to achieve a certain goal. If you have a 240 bushel yield goal, you need to be on this 30 pound line. You could be anywhere from a 0.32 all the way up to a 0.4, and that leaf tissue would quantify for that range. But it doesn't mean that because you're at, say, a 0.4 that you're going to be at 240, because here's another one at 0.4 that has less accumulation associated with less yield. Okay, the correlation of content and leaf tissue concentration is 0.0051. For nitrogen, that was 0.0033. So both nitrogen and phosphorus have very low R-squareds when it comes to fit. They don't correlate to each other hardly at all. From our data last year, I wanted to show you the role of excess phosphate. And this is from an example of two fields from the same client that used Agrimodis last year. And I highlighted these two fields, the P1 on the soil test. Field 1 was 75, field 2 17. So because it only had 17 ppm, the applied phosphorus on the field last year was 116 pounds of P2O5. Field 1 still got 52 pounds. All right, now enter the new information. Here's the total crop uptake in phosphate. Field 1 had 103 pounds. Field 2 had 117.5 pounds. Now look at the yields in the next column. The field that took up 102 pounds out-yielded the one that took up 118 pounds by about 7 bushels per acre. So these are really statistically about the same. The thing is, your phosphate was excessive in both. It was just more excessive in this one. Where we applied 116 pounds of phosphate, we're about 40 pounds over what we actually needed to achieve the yield. And in this field, we're about 25 pounds over. So it's a way of looking at, do I need to keep putting this much out, or can I make a strategic cut in that phosphate need based on what the plant finds? So in the data from last year, this is the nitrogen the number of samples between tassel and maturity that had excessive levels of nitrogen, and it was about 2/3. For phosphate, it's over 90%. And the average excess of all of those was 37.8 pounds per acre. So it really falls in line with that previous slide we saw, that there's a lot of excess phosphate coming up into that crop. In the way of what does that account for right now at 90 cents an acre? You're talking about $34 an acre roughly. So if we look at that previous slide, that is, one is about half of that. One, you could probably do a cut of about 40 pounds. So you can save anywhere from $15 to $30 conservatively by identifying a luxury phosphate level of consumption in your crop. So Agrimodis can help you do that. So just a quick thing on leaf tissue and how to identify whether or not you can use intelligent cuts for your phosphate program this year. All right. Thanks for your time.